All right, folks, here we are on page 173, miscellaneous number 1. All right, so they've given us this x is normally distributed with a mean of 30 and then a variance of 49. And then giving us y, it's also a normal distribution with a mean of 30 and it's got a variance of 16. And then I've got another one here that's got z, it's a random variable. But let's go look at these first two. First I've got x, and let's think about that. The mean is going to be 30. And the standard deviation is going to be 7, the square root of 49. Now, basically, let's kind of think about what that means. The center of the graph is going to be at the mean. So let's go ahead and label this 10, 20, 30, 40, 50, 60, 70. And then we got this general shape. It's going to be a bell-shaped curve. So let's come over here on the side, this kind of little sketch here. It's going to kind of look like that. And we know that's going to be the mean. That's 30. All right, now what we also know is the standard deviation is 7, and we know that most of the graph is going to be within 3 standard deviations of the mean. So if I take 30 and add 21 to it, well, that means that most of the graph is going to be within 51. And if I take 30 and subtract 21, well, then I'm going to get 9. And so most of my graph is going to go from 9 to 51. Now, take a look at the other one. It's got a standard deviation of 4, where the first one's got a standard deviation of 7. Now, you'll notice the mean is the same. So it's also going to have a center point at 30. But what's going to happen is that this graph is going to go from 30 plus 12 over to 42, and 30 minus 12 to about 18. So now this graph is going to go from 18 to 42. It's going to be taller. So basically, if I put them on top of each other, this one's going to be kind of like that, and the middle will be 30. And then when I put this one on there, it's going to be centered around the same spot, the same mean, but it's going to be taller because the standard deviation is smaller. The data should be less spread out. So let's try to do this on the actual paper. So we got 30, and I'm just going to put it here. It doesn't make a difference really exactly how high it goes. So I'm going to put it right here, and that's going to be our x. All right, and now I know that most of the graph is going to happen between 9 and 51. So I kind of just give a little sketch here. And then I know the other one, it also is going to be a mean of 30, but I know it's going to be up here, it's going to be taller, because what's going to happen is most of this graph is going to go from 18 to 42. So if they both have an area of 1, but they have smaller boundaries, obviously the one's going to be taller. Now, if I look at the last one, you'll notice that it's got a mean of 50, but it also has a same standard deviation of 4. So if I go 50 plus 12 and 50 minus 12, those are the kind of boundaries for that. That's 3 standard deviations. Most of the graph must be within 38 to 62. But I know it's going to go the same height as the other one. So the mean's going to be at 50. So if I plot that point, and then I just got to go and kind of swoop down till I land around 62, and then swoop down till I ran around 38, and then I'm going to have that curve. And again, keep in mind, this is just supposed to be a sketch. And now I'll label them x, and then the second one was y, and then the last one is going to be z. But basically, they're just trying to get at, okay, you got standard deviations, and 2 different standard deviations in the same mean, and then the same mean, but different standard deviations. All right, hope that helped. Thanks for watching.